All right, here's how you do question number one. We are talking about scientific notation, which is just another way of writing a number. And the way you write the numbers using this template you can see on the screen right now. Okay, big box, you need to write a number that is between 1 and 10. Okay, no number bigger than 10 can be written in the box. No number smaller than 1 can be written in this box. Okay, so and the little box on top of the 10 is the exponent of the 10. And that will tell you how many times you move the decimal point to make a large number be written in scientific notation. So in this problem, they gave us the problem or the big number, 567,843,000. And basically, this big number, I need to rewrite it using scientific notation. First thing I suggest you do, find the decimal point of the number that was given to you, the large number. When you do not see it, it's because it's all the way on the right end. Okay. Now you wanna move the decimal point. You wanna place the decimal point in a new place. Okay, so this big number becomes a number between 1 and 10. And that place will be right here between the 5 and the 6. Okay, this is the old place. That's where the original decimal point was. This is where I want it, new place. And why? Because I want to make this big number, I want to convert it into a number between 1 and 10. So if I put it where is the new place of the decimal point, I'm going to have the decimal number 5.67843. That number's between 1 and 10. Now ending zeros we don't write. And then I need to find out what will be the exponent of the 10. And basically what you do is you're just going to count how many times you move the decimal point between digits, like I'm doing right now. You see I'm doing these little arcs. And I'm just counting how many times I move the decimal point between the digits. And you can see I move it. See, I'm counting the little arcs. I move it 8 times. And you can see that will be letter A. Okay. And that's how you work this problem out. All right. For problem number two, they gave you the number in scientific notation. They gave you the number 1.06 times 10 to the 8th power. This number is written in scientific notation because this number here, 1.06, is a number between 1 and 10. Okay. And every time you have an exponent that is positive, okay, it means that we're working with a large number. So we have a large number that was written in scientific notation. Here's what you have to do. You're going to take this 10 to the 8th power, and let's find out how much is that. Okay, 10 to the 8th power, it means you're going to have a 1 followed by 8 zeros. And you're going to take that number and you're going to multiply that by the 1.06. And basically, when you multiply that, you're just taking the decimal point of 1.06. This is a shortcut to multiply by powers of 10. We call this a power of 10. Okay? Because our base is 10. Okay? And there's a shortcut to multiply any decimal by a power of 10. Count how many zeros you have, and you can see that I have 8 zeros, which is the exponent. And you're going to take the decimal point of 1.06, and you're going to move it 8 times to the right. So 3, 4, 5, 6, 7, 8. Now the decimal point is all the way over here at the end. This was the original place of the decimal point. Now I'm going to have it at the end. This is the new place of the decimal point. Now, can you see I have like empty pockets? These little arcs, I call them pocket. And basically what I'm going to do is I'm going to fill it in with placeholders, which are zeros. And my new number is going to be, now remember this decimal point, the original decimal point is no longer there. So my new number is 106, and then it's going to be followed by 6 zeros, which basically means that I'm working with 106 million. So this is the large number that was represented by the scientific notation. And that's what I'm going to choose here, 106 million, which is letter B. Okay, I hope that helps. Okay, here's question number 3, and they gave us a large number. Wow, this is a big number. This is 1,450,000,000. Okay, that's how big is this number. Now, I want to write this number in scientific notation. Okay, first thing I suggest you do, find the decimal point. And the way you find the decimal point, when you do not see it, it's all the way on the right end. And you want to place the decimal point between digits until you get a number that is between 1 and 10. So I can write it in the big box. And the right place will be right here between the 1 and the 4. Okay. And what I want to know is how many times I move the decimal point from the original place. Okay. I want to know how many times I move it to the new place. So let's count. Let's move the decimal point between digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I moved the decimal 9 times to the left to make this large number into a number between 1 and 10. The number that I got between 1 and 10 is 1.45. We do not need to write the ending 0. And I moved the decimal point 9 times. Okay, you can count the little arcs here that I did when I started moving the decimal point from the original place to the new place between digits. Okay, and that's what I'm going to write in here, 1.45. And then I'm going to look for the time symbol. Oops, let me erase that. I did one division. Okay. Times, and then I write 10, and then to the power of 9. And that's how you do this problem. Here is question number 4. Same idea. Okay, guys, same idea. Okay, I'm going to take this large number, which is 14,520,000,000. And then I have 6 zeros after that. Okay, this is a very large number. I want to rewrite this large number in scientific notation. So first thing I'm going to do is find the decimal point of this large number. When you do not see it, it's all the way on the right end. And I want to place it, the decimal point, I want to place it in a new place, in a new location between 2 digits. So I get a number between 1 and 10. That's going to be right here, okay? So this is the original place of the decimal point, and this is where I want it now. This is the new place. Why I want it there? Because I'm going to get the following number, 1.452. All the zeros after the 2 are ending zeros. We do not need to write it. And that number I wrote in red in the box is between 1 and 10. That's the reason. And then I need to count how many times I moved the decimal point from the original place to the new place. Move the decimal point between digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how many times I moved the decimal point. And remember, when the exponent is positive for the power of 10, it means you're working with a large number. Okay, let me put the answer here. So I'm going to put 1.452 times 10 to the power of, and I forgot what did I put in there. Let me see what did I put in there. Also to the 10th power. Okay, and that's how you do this problem. All right, here's the next problem. Problem number 5. Same idea. I'm going to take that large number, 2,459,000. Okay. And I want to write that large number using scientific notation. I'm going to rewrite it in scientific notation. Find the decimal point of this large number. When you do not see it, it's all the way on the right end. This is the original place of the decimal point. Okay, but I need to move the decimal point between two digits until I get a number between 1 and 10. And that place will be right here between the 2 and the 4. Why? Because if I put it there, I'm going to have 2.459. And in zeros, we don't write it. That number I wrote in red in the box is between 1 and 10. Okay? And I just need to count out how many times I move the decimal point to the original place to the new place. So 1, 2, 3, 4, 5, and 6. That will be how many times I move the decimal point from the original place to the new place. And that will be my answer. Let me write that down. 2.459 times 10 to the power of, I believe it was 6. I'm going to have to verify that. Okay, yeah, to the power of 6. And that's how you work this problem out. All right, here's question number 6. They gave us a number in scientific notation, 6.3615 times 10 to the fifth power. Okay, 10 to the fifth power, this here means that you have a 1 followed by 5 zeros. Okay, that's what this means. And you're going to multiply 100,000 by this decimal. Now, one quick way to multiply mentally by a power of 10 by a number that ends, that has a 1 followed by zeros, just count how many zeros you have. And you can see you have 5. That's the exponent. And what you're going to do is you're going to take the decimal point of your number and you're going to move it 5 times to the right. When the exponent is positive, it means we are working with a large number. And to make this number 6.3615 larger, we need to move the decimal point to the right 5 times. So 2, 3, 4, and 5. Now, this is where going to be my new place for the decimal point. This was the original place. And what I'm doing is I'm moving the decimal point between two digits. Okay. Now I have an empty zero, an empty space at the end after the 5 before the decimal point. We put a placeholder, which basically is a 0. So what would be our new number? Well, the original decimal point is no longer there because I move it to a new place. So the original number is going to be 636,150, which basically is going to be 636,150. Okay. You don't need to put the comma. Okay. In fact, I'm going to take out the comma. It's not necessary. So I'm going to leave it like that. And that's how you do this problem. Here is question number 7. If you read the problem, they're talking about the population of China. It says that the population of China is 1.402 billion people. Okay. The word billion, if you write this word mathematically, it means you're multiplying by a power of 10 with exponent 9. That's a billion. Okay. So basically it means it's like we have a 1 followed by 9 zeros, and that will be the billion. Okay, and I'm going to multiply a billion by 1.402. But don't do this in the calculator. You're going to have to do this mentally, and the calculator is not going to work out because the number is so big, it doesn't fit in the screen. Okay, so how do you do it mentally? Very simple. Count how many zeros you have. Okay, and you see you're going to have 9, which is the 9 you have as an exponent. And take the decimal point of 1.402, which is located right here, okay? And that's the original place of the decimal point. And what you're going to do is move it 9 times to the right, okay? To make 1.402 a large number. So you're going to move the decimal point between digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now my decimal point is going to be here. This is my new place. Okay. Over here was my original. What do we do with the empty pockets? I like to call these arcs that there's no number inside, pockets. So we're going to put placeholders, which are zeros, okay, inside of each one. And my original decimal point is no longer there. So that means I'm going to take it out. It's now going to be all the way on the right end. So my new number is going to be this: 1,402,000,000. Okay. So 36, yeah. One. And this is the large number that 1.402 times 10 to the 9 power was. So 1,402 and then followed by 60. And that's how you do that problem. Here's problem number 8. Same idea as I did in number 7. They gave us a number in scientific notation. Okay. So 6.1111 times 10 to the 7th power. 10 to the 7th power means a 1 followed by 7 zeros. So 1, 2, 3, 4, 5, 6, 7. That means I'm going to multiply 6.1111 by this large number. But don't do it in the calculator. It doesn't fit in the screen. So here's the shortcut. Count how many zeros you have. And you're going to see that it's the same amount as the exponent. So you're going to take the decimal point of 6.111 and you're going to move it 7 times to the right because the exponent is positive. It's a big number. Okay, so we're going to make it 6.1111 a larger number. And I'm going to move the decimal point between digits. So I have 1, 2, 3, 4, 5, 6, 7. Now my decimal point is going to be here. This is my new place of the decimal. This was my original place. However, it's no longer there. Now what I do with the empty pockets, the arcs that are empty, there's no digit inside, put a placeholder, which are zeros. And your new number now by taking the decimal point, the original decimal point, taking it out, now in the new place, it's going to be a 6, 4 ones, and then 3 zeros after that. Which basically it means it's going to be 61,111,000. And that's what I'm going to write here. 61,111,000 and then 30 at the end. Okay, let me make sure I wrote this correctly. So 6, 4 ones, 3 zeros. There you go. And that's how you do that one. Okay. Here's problem number 9, the last one of this homework. And they ask you to do the following. A bee flaps its wings about 8.28 times 10 to the 4th power. This is the bee. Okay. A hummingbird flaps its wing about 28,800 times an hour. So here's what you're going to do. You're going to take the 28,800, which is the hummingbird, okay? And you're going to take that number and you're going to make it in scientific notation first. So I'm going to take the 28,000 and I'm going to write in scientific notation. I know it's all the way on the right end, the original decimal point. I want to place it between, I want to place the decimal point between 2 digits. So I get a number between 1 and 10. If I put it here, okay, I'm going to get 2.8 and then followed by another 8 and then 2 zeros. But I'm not going to write the ending zeros. And then I'm going to count how many times I move the decimal point from the original place to the new place. So 2, 3, 4. So I'm going to write times 10 to the 4 power. Okay. Now, why I did that? Because they're asking you to estimate how many times the bee flaps the wings more than the hummingbird. And basically, you need to have the same power of 10. So this here of the two numbers must be the same. If they're the same, the only thing you have to do now is subtract the decimals in front of it. And using your calculator, which I'm gonna get right now, here is my calculator, okay? What I'm gonna do now is I'm just gonna subtract 8 point, let me move this out of the way, 8.28, whoops, let me clear, 8.28. I'm gonna subtract 2.88, okay? So basically, I could have said this is around 8, this is around 3, 8 minus 3 will be 5. You can see the exact answer is 5.4, but they told me to estimate. So when you estimate, you're going to take this decimal and you're going to round it to a whole number. So this decimal is basically 8. This decimal here is basically 3, and 8 minus 3 will be 5. So that's the answer I'm going to put here. That's my estimate. Okay, and that's how you do this assignment. I hope this helps.